Okay, now we'll talk about power, which is section 6.4. We will see the effect of the time on our calculations when we need to calculate work and the force. Does the time has any effect in our system? We will see that. If this is you and this is me, we both need to move an object for a distance, the same distance, which is x. But you spend time delta t2 and my time was delta t1. If we need to compute the work, it is simply F multiplied by x, which is the distance, and the same for my work. If my force is the same as yours, okay, and x is the same between us, then our work is the same and my action is the same as your action. But what if your force is more than mine? Then you will finish your job before me and you will spend time less than me. Okay? In general, the work is the same. The work is the same because we have the same distance done by the same work. But now we have a different times. If your time is less than mine, then your work is more efficient than me. And you are better than me in doing these things. Okay? These words, we will talk about power. In this case, your power is more than my power. Because you did the same work but in faster than me or in time less than my time. So the power, we have two kinds of power as we see from before. The average quantity of power, which is the work, the rate of work with respect to time, delta W over delta T. And the instantaneous power will be equal to the limit. When delta T goes to 0, it will be dW over dt. So the work divided by the time spent is the power. So if you did the same work with less time, then your power will be more. Okay? Also, we can write the power in terms of force and velocity. Since W is equal to the force multiplied by the displacement, and we know that the power is dW over dt, and dW is F over multiplied by ds over dt. We can take dt for just ds. ds over dt or dx over dt, it is the velocity. Now we have the power is equal to, instantaneous power is equal to the force multiplied by the velocity. Okay, now we have two relations for the power, which is, the first one is the work divided over the time, dW over dt, or F multiplied by the velocity. And we can say that the time rate at which work done is the power. Also, the velocity of the acting force or the force velocity acting is the power. So, the time for the work or the velocity for the force are the power. If your time for your work is short, then your power is high. If your velocity, when you are doing a force, your velocity is high, then your power is also high. As we see, the power is a scalar quantity and its unit is joule over second, which is a watt. Okay, we all of us know the horsepower and if we need to convert from 1 horsepower, it is 746 watts. Okay, let us look now at this example, calculating the power, the work, the kinetic energy, and something for a moving object. If we have this object, we need to move it from point A to point B on some level. Maybe this angle is equal to 0, maybe it is not equal to 0, and the distance that we need to move this object along it is L equal to 4 meters. And we act by a force equal to 200 newtons. We need to find the velocity, which is a constant, and the time that's spent to move this object from point A to point B is 10 seconds. We need to find the work to move the object from A to B. Then, during the given time, we need to compute the power. We need to compute the velocity. We need to compute the kinetic energy. If you look at this question or this problem, we have many requirements for this system. It is just one line for each one of them. You will see that. For example, the first one, the work, is equal to F multiplied by S, which is FL, which is equal, the force is equal to 200, and the distance is 4. Then we have done 800 joules. What about the power? The power is the work divided over the time, delta W over delta T, which is 800 over 10, which is equal to 80 watts. Okay, what about the velocity? We have another way to compute the power, which is the velocity of that force. The force is known, the power is computed now. We need to compute the velocity. The velocity is P over F. We need to divide over F, the both sides. P is 80, the force is 200. The answer will be 0.4 meter per second. Okay, and we have also another way to compute this velocity, which is the distance L over the time 10 seconds. 4 over 10, it will be the same, 0.4 meter per second. What about the kinetic energy? The kinetic energy, the work done on this system is equal to the change in kinetic energy. If the object was at rest at the beginning, then its kinetic energy later related to the work done. The work done is 800 joules. Then the kinetic energy will be 800 joules. And again, we can find it by its relation, which is half mv squared, the mass. It is not given. The velocity is 0.4. We need to square it. Half multiplied by the mass multiplied by the velocity is equal, squared is equal to 800. We can find the mass of that object if we like to do that. And that's it.